I'm Chrisferb, and I'm going to review how to perform factor analysis in SPSS. So first of all, I want to give credit to the person who either created this or modified it and posted it, but how I found it. So it looks like it was a Dr. Andy Field. In one of his examples, looks like in 2005 he posted this for his class. Looks like research methods factor analysis on SPSS. So I found the file, and the file is really good, and there's a little example description to go with it. So if you have a chance, you should search for that, and you can find the file that's like, it's labeled SAQ.sav is actually the data file. And so it's Dr. Andy Field. I want to give him credit. Okay, so today I'm mainly looking at how to perform a basic factor analysis, and in a future video I'll explain more into the key parts to look at. I'll briefly hit on them in this video, but mainly I want to show you the quick and dirty kind of how to do it and what to look for. And so factor analysis is used often when you take for instance a survey and you want to see commonalities between the questions. Let's say you ask if somebody's lazy in a personality survey. You ask that from multiple angles, and then you want to be able to combine them, let's say make a laziness factor score. And so that's what you could do with this. It actually looks for the relationship between questions and shows how strong that relationship is. And so along with that, some people could use the factor analysis output to assess if somebody's going to be a good employee or not, which is a big topic. If you exclude people, it's considered a type of test, and you can be guilty of discrimination if you use a test that isn't verified to actually produce the type of results that you are saying that it produces. So one of the things is you can do factor analysis and see if it's actually testing what you think it does. Okay, so we'll get started. I have that file open. That's SAQ.sav is actually the file name. So if you search for it, you can find that from a Dr. Andy Field. Thanks again for the file and the example. So this is the file I have open, and so we have a bunch of these questions, and then these are the responses. It looks like it's similar to a Likert score, strongly agree, strongly disagree type of thing, I believe. Okay, so we're going to get started. So factor analysis. Now I'm using SPSS, I believe, version 24. It's pretty similar, I think, going back a couple versions. So we click on Analyze, Dimension Reduction, and then it says Factor. Now all of these I've already selected, but let's take a look. So I've already practiced this just to make sure I don't have any weird things that show up for you guys. And I'm going to move these back just to show you. Okay, so when you first open up the file, what you'll see is all of these questions in here. And so what you want to do is click on the bottom one, let's say, or the top, and then hold down the Shift key. I'm having difficulties here. Hold down top one, and then scroll down, hold down, and then select the last one, so you can select them all. I wish they had a select all, but they don't. And then we move them all over. So now we're working with all of our variables. So there's a lot of options in here. And honestly, when you do factor analysis, there's a lot of different ways to do this. There's a couple of the key things I want to show you that will help you decide if the data's a fit for it or not. So a lot of these things, a couple of these things I'll talk about. Some of these things I may talk about in a future video. But some of the significance levels, the KMO and the Bartlett's test of sphericity, I can't say it, like a sphere, anti-image, reproduce inverse. And so there's a lot more to go with this. But I have all these checked so you can see. And then extraction. So we're going to do the correlation matrix, unrotated factor solution scree plot. I'll show you the scree plot based on eigenvalue. I can't pronounce that name, but usually what they do is they have a cutoff, and that's it's essentially saying above or below this point, they seem to be not as correlated together. And there's actually about 3 different ways to decide which variables you should include, or factors, I'm sorry, you should include in this. And this is just one of the ways. You can use the scree plot. And then maximum iterations for convergence, 25 or 30. People sometimes do more. And this is like, if you think about it's recursion. It's kind of doing math back into, it's if you think about a matrix, it's like going through all these steps and comparing the variables. If you think about doing this by hand, it would be horrible, and that's why you do this on a program. So I hit continue. The next one, I'm going to look at rotation. So I'm going to use Varimax rotation. It's one of the ones that Dr. Andy Field uses. One of the other ones, there's different ways to do it. And then display, rotated solution. So I do want to see the rotated solution, the loading plots. And then it says maximum iterations for convergence 30. And like I said, I could talk for a long time on this as I keep digging into this. They're using the Anderson-Rubin, which is what was recommended in the example. Display factor, score, coefficient matrix. That's fine. Oh, actually, I don't want to check this one. It'll save variables, and I don't need to save the variables in my data set. I noticed that from the earlier trial. So I clicked OK on that last one. Now we're in options, and it says excludes case pairwise. I believe that one excludes the empty fields, which is what we don't need. Sorted by size, suppress small coefficients, absolute value above 4. So this is one of the things where we're trying to eliminate some of the coefficients that are below 0.4. So if you think about regression, once we get, if we think about on the Pearson's R score with a regression, we have +1 as a perfect correlation, -1 is a perfect negative correlation. So what they're saying is, now people actually, when you look at these, and I've been studying factor analysis, you can find all kinds of recommendations. So 4 is fine. Some people would recommend higher, some maybe lower. If you go too low, it's not really that correlated, so we'll just keep it at 4. I think I hit all of the options, so I'm going to hit OK, and then we're just going to look at some of these things. I have a bunch of screens, so it opened up in a different window. That's fine. I'll pull it back. So this is descriptive statistics, so that's fine. There's a lot of data that's produced with this. If I went back through, I could eliminate some of it. So this is descriptive statistics on the values from, say, the survey, which is fine. Correlation matrix. So what you'll see is a score of 1 on some of these, and it's because it's a matrix, and when it says statistics makes me cry, you'll see all of the variables are compared to each other. So it's also compared to its own question, which is statistics makes me cry. So there's 100% correlation, of course. So you'll see that that's a diagonal that goes all the way through. So there's a lot of different data in here. Now there's a couple things that you can do. There's recommendations in here where you say you shouldn't have. There's different recommendations. I'm going to talk about it on a different video. Essentially, I believe you don't supposed to have complete rows that are overly correlated, because that means this test isn't proper for that type of deal. The other thing is that we go down and we take a look at this one, and it's called the coefficient determinant. And so this is supposed to be under, say, 0.05, and so it is. So that means the coefficient determinant is significant enough for us to work with. So that's one of the things to look for. And then it goes through the inverse. Some of these tests test to see if there are the identity matrix is there, because that would mean that the test isn't appropriate for it. And along with this test, the other thing is the data is supposed to be normalized. So let's look at the KMO and Bartlett test. So that's the Kaiser Meyer Olkin measure of sampling adequacy. So is the sample adequately large? So right here, it's supposed to be a high number, closer to 0.9 from what I understand, and up is good, so that's a good number. The other thing for Bartlett's tests of sphericity, I can't say it right, but like a sphere, spherical, I guess. So this is another one where you want this significance level, you want this output to be really low, because that means our findings are more significant, or that's the way it works. If you end up having a really small sample set, then you can never get very accurate outcomes when you look at the significance. So this number is supposed to be really low, smaller than 0.05, which some of you guys with statistics remember that's usually a statistical cutoff. And then this one's supposed to be very high, around 0.9 or on the high end. Like I said, everybody disagrees on what the cutoff should be. So, like I said, in the future I can go into more of these, but for now, there's a lot of different things in here. Commonalities, I'm going to show you. So then we get down to the total variance explained. You start to take a look at the amount of variance that's explained with our calculations, and the big thing here is we're looking at it. Some of these top four you'll see have a high amount of variance explained, and from what I understand, once you get into this top four, if you have a correlation between them, then this is kind of showing that a lot of the variance explained is in the top four. Scree plot. So with the scree plot, you can take a look at where they say there's an inflection in the graph, and they say once you get past that, then it's not as the factors aren't as useful. And so what they usually say is, oh, you should draw a line. So we picked the eigenvalue at 1, so that would be somewhere right around here, and so the cutoff is around 3 or 4 if we draw a line across. Component matrix, it's not as descriptive yet. Reproduce correlations, I'm not going to talk about this. Rotated component matrix is kind of the final outcome where you have a super usable outcome that you can work with. So let's take a look at this. So this made 4. It picked 4 of the values, and I believe you can actually do more. There's more below. This is the big thing I want to talk about, though. So we have a couple things here, and this is where we'll take a look at what these factors are. So for the first one, this is the highest, and so it's in order of factor 1. So this would be our first factor, and it says, I have little experience of computers. SPSS always crashes when I try to use it. I worry that I will cause irreparable damage because of my incompetence. So this is all essentially has to do with, the reaction to computers, let's say. So these are all, what this means is these are correlated, meaning they're kind of asking the same type of question from different angles. So that we could say is familiarity with computers or lack of familiarity with computers, however this is framed. For the next one, this is component 2. This would be our second factor. It says, I can't sleep for thoughts of eigenvectors. I wake up under my thinking that I'm trapped under normal standard deviation. So this looks like a fear of like statistics. Yeah. So for the second one, this has to do with people that has to do with statistics. Now you can see it's not perfect because this one right here, it's split. So this says this talks about SPSS. And so it's split between these two things. And it's probably because the SPSS is a computer program, and it has some correlation with the computer parts, but it also has correlation because SPSS is usually used with statistics. So this could be statistics right here. The next one is this one's mathematics. That's component 3. And then component 4, my friends are better at me than statistics. My friend. This is about friends and maybe the perception of how they feel close friends and relationships think about him with statistics, I guess, mathematics. So it's outward perceptions. So this is the main reason why you do factor analysis. So what you can do with this is you could go and look at this, and you can study these more, and there's a couple things. Your questions, when you ask a question from different angles, it's usually harder to manipulate the test, because if you ask it from different angles that is showed to be correlated, it's harder for somebody to just essentially provide fake answers, I guess. And the other thing is you can go through and you can study it more, and you can actually go and you can improve your test, and you can make sure that it's testing what you believe it's testing, and you end up adding validity to the test, barring lots of other factors. The other thing is with factor analysis, you can look at, I've seen examples where you can look at country data, you can look at economic data, GDP, and all these things, and you can actually see what the correlations are between certain factors between countries that may have been harder to discern. And so that's one of the interesting examples I've seen using factor analysis essentially for data mining. So I hope that you learned a little bit about how to do that. There's other things here, and some of this stuff is a little bit fluffy, I'd say. This shows the relationships between these 3 factors: component transformation, component score. So there's a lot of output. As I learn more, I'll probably take away some of these outputs, because they're just not. Some of them are more useful than others, of course. The big thing is you want to make sure that you do a preliminary assessment to see if your data is right for the analysis which we did. And then you want to go through and you want to make sure that when you do the test, you actually have some output that is useful. So thank you. Keep an eye out for the next video.